has about 1 million eggs inside of those ovaries. So that means that one female child, on the day she's born, she has about 2 million eggs in her ovaries. Now, for the first 11, 12 years of life, she's reproductively inactive. In other words, she is unable to conceive. And what happens in those first 11, 12 years of life is that the majority of those eggs die off. So that by the time that she reaches puberty, around 12, 11, 13, whatever, depends on the female, she has about 300,000 to 400,000 eggs left over. So most of them die. Now, she only releases this many eggs every month, sometimes 2. That's where you can get non-identical twins from. Okay? However, there is no way, if she releases 1 egg a month from puberty until menopause, 50, 55, 60, depending on the female, that she's ever going to release that many eggs. It's biologically impossible. Throughout her reproductive lifetime, she's going to release about 400 of those eggs. So this is overkill by thousands upon hundreds of thousands of eggs. And we think this is designed this way to ensure reproduction of the species to the next generation. So, 400 eggs from ages 12 to, I'm just going to say 55, and again, it depends on the female. And at 55 or so, she starts getting to the point where she cannot release any more eggs from her ovaries. And this stage of development is what we refer to as menopause. And menopause, she can't release any more eggs, and the reason she can't do that is because something called the follicle, and you don't know what the follicle is, but the follicle degenerates. And when the follicle degenerates, and I'm going to talk about this on Monday after Thanksgiving, when the follicle degenerates, she is unable to release any more eggs. So she can still have sex, but those eggs are inside her ovary. Sperm can't get into the ovary. If sperm can't get into the ovary, she can't be pregnant. She can't get pregnant. It's impossible. Okay? So that's just a very general overview of some of the things that we're going to talk about. Okay, this is perhaps the hardest slide of female reproductive physiology, because what this slide does, and it's in your book, I took it directly from your book, this book looks at production of the egg. The egg, okay, the egg is referred to as the oocyte. So the oocyte is the egg. O-O-C-Y-T-E. The oocyte is an egg. That's what it is. And the process that you see up on this diagram, bless you, is the production of the egg. In other words, the generation of the egg. And the generational production of the egg is what we call oogenesis. Because genesis means beginning. Okay? Beginning of what? Beginning of the oocyte. That's why the process is called oogenesis. To make it a little bit easier, what I've done is I've actually broken this down into 3 phases based on time. Anything above the first line are the events that happen before a female child is born. So in other words, when she's in the uterus of the mother. Day 1 to year 12, roughly, that's childhood. At puberty is this line. So from puberty to menopause, this is what happens. Those events happen. Okay? So there's your timeline. So let's do this. Let's start up at the top with the events, the first events that happen. Now, you know from basic biology that in order to produce a child, you have to have sperm and egg. And half of the genetic information comes from the mother, and half of the genetic information comes from the father. Okay? Now, so you and I are products of fertilization and products of our parents' genes. Most every single cell in our body is what we call diploid. Now, I'm talking about the number of, or the amount of genetic information, okay, the number of chromosomes in our cells. So most cells in our body are what we call diploid. And the way we write that is like this. We write that with 2 and then small n. 2n means we are diploid. We have the full complement of genetic information in most of our cells. What are the only cells in our body that are not diploid? The gametes. In other words, our sex cells, eggs or sperm. They are not. They are, what's the opposite of diploid? Right. They are haploid, and the way we write that is N for each individual. So when fertilization occurs, half the genetic information comes from the mother, half the genetic information comes from the father, and when that happens, we get a diploid cell, like that, okay? Basic genetics. Dr. Donzi Rana will be looking at me saying, really? You're telling him this? Yes, I'm telling him this. There's a reason for this. Now, if you look at the timeline here, is the first cell that's made, is that a haploid or a diploid cell? Is that a haploid or a diploid cell up there? Diploid. It's a diploid cell. It's a 2n cell, isn't it? You can't have that. That's too much genetic information. Only half of the genetic information comes from the mother, right? So what happens to that cell? That cell is what we call an oligonium. That's the name we give the first cell that is made. And that is a stem cell. Okay? It's a stem cell. It's called an oligonium. It's diploid. Now, that cell divides and reproduces by mitosis. And you know mitosis, you start off with a 2n cell, you get another 2n cell. It's an exact copy of the original cell, right? It's a duplicate cell. So I am not only going to require you to understand the events in mitosis, I'm going to now require you to know the events in meiosis, which is basic biology. You should remember mitosis and meiosis from any biology class you've taken before this. I expect you to know the events that happen in both of those areas, okay? And that's in your textbook. That's on just after chemistry. I don't know what chapter it's in, but it's in your book, right? So, as a result of mitosis, any resulting daughter cell from an oligonium is what we call a primary oocyte. Is it diploid or haploid? Right, it's still diploid. Okay, it's still diploid. Now, so you've got a primary oocyte. Now, this is what happens. This is what happens before birth, right? In the fetal stage of development. Now, what happens when a female child is born? Well, what happens is this. Each one of these primary oocytes start to divide. And they start to divide by meiosis. However, they don't finish meiosis. Okay? They don't finish meiosis. So all of these 2 million oocytes, when a female child is born, are primary oocytes. They're still diploid cells because they haven't finished meiosis. And this is why they haven't finished meiosis. They are stuck in a phase of meiosis called prophase 1. Remember you have prophase, metaphase, anaphase, telophase? You have that in meiosis and mitosis. They are stuck in prophase 1. So when a female child is born, all of her oocytes are stuck during childhood, between the ages of 1 and roughly 12, they're stuck in prophase 1. Now, the majority of those cells die. Remember you start off with 2 million, you end up with 300,000 to 400,000, so the majority of those cells die. Once year 12, 13, whatever happens, puberty, I repeat, one of these primary oocytes finishes the division of meiosis 1, So it completes meiosis 1, and as a result of that, produces 2 daughter cells. One daughter cell is called a primary, or the first polar body, and the second daughter cell is what we call a secondary oocyte. What can you tell me about these cells? Are they haploid or diploid? They're both haploid. So the result of the first division of meiosis is you produce 2 daughter cells from that diploid cell. Both of these are haploid cells. One of them is called the first polar body, the second one is called the secondary oocyte. And what's going to happen, and I apologise that I haven't got time to finish this, what's going to happen on the Monday after spring break is I'm going to show you what happens to each one of these daughter cells and which one could get fertilised if sperm would eat afterwards. Have a happy Thanksgiving.